Okay, hello everyone. So I'll be going through the homework for Pythagoras theorem. I've assigned 5 questions, 3 from exercise 8.1, okay, question 6, 7 and 10, and 2 more from exercise 8.2, question 9 and 16. Okay, so let's begin. Okay, so the 3 questions from exercise 8.1, there's no story, there's no context to it. So it's just straightforward questions. Okay, so over here, if you see, we have 2 right angle triangles. Okay, we have ABD and we have CBD. Okay, these 2 are right angle triangles. So over here they tell that BAD, this angle is right angle, BDC, this angle is right angle, 90 degrees. They tell that AB is 3 cm, AD is 1 cm, CD is 2 cm. So first they ask you to find the length of BD. Okay, so applying Pythagoras theorem, basically Pythagoras theorem tells you the relationship, okay, between 3 sides of a right angle triangle. Okay, so as long as you know 2 of the sides, you can find the third. So in this case, if you're looking at BD, okay, we won't use triangle BCD because over here I only know one side. I don't know this, I don't know this. Okay, so in this case I'll use triangle ABD. Since I know this side, I know this side, I know 2 sides, I can find the third side. Okay, so we apply Pythagoras theorem. So applying Pythagoras theorem. Okay, so I think in class I said instead of writing as a bracket of Pythagoras theorem, I write by Pythagoras theorem. Okay, so I think that main thing is you need to state that, okay, this comes about because you're applying Pythagoras theorem. Okay, it does not just pop out of nowhere. Okay, so in this case, remember Pythagoras theorem. Okay, the sum of the square of the 2 shorter sides is equals to the square of the hypotenuse. Okay, so in this case, this is my hypotenuse, is the longer side that is directly opposite your right angle. So BD square will be equals to AD square plus AB square. So in this case, D square will be equals to 1 square plus 3 square. In that case, you get 10. Okay, then you need to square root on both sides. Okay, key thing to take note over here in the textbook, they missed out on something for all their steps. Okay, in Pythagoras theorem is that they did not do a plus minus sign when they take a square root on both sides. Okay, this is very important. Okay, on your own work, please make sure that every time when you take square root on both sides, you do a plus minus. So in this case, this should be BD equals to plus minus square root of 10. Okay, and you take plus minus, this means that you will need to reject the negative value. So your answer should be BD equals to 3.16. Okay, cm, and then you have a bracket reject negative 3.16. Okay, so once you have this, okay, next part B, okay, they ask you to find what is BC. So now you already have BD, you know CD, you can find BC. Okay, so you now have 2 known sides, you can find the third side. Okay, so this BD is actually your 3.16. But instead of using a 3.16, which is a rounded off value, okay, it's important that you should use the value before rounding off. But let's set up the equation. Okay, so BC square will be equals to BD square plus CD square. Okay, so this square, the hypotenuse square will be this square plus this square. So in that case, let's write that down. So BC square will be equals to 2 square plus. So like I said, okay, instead of using all the rounded off value as 3.16 square, I use the full value, which is square root of 10. Okay, square root of 10 is before rounding off, it carries everything. Okay, and when you substitute into square, you realize that if you take the square of 10, you are just left with 10. Okay, it will be an exact number, there's no rounding off. If you go and use your calculator, you try to take 3.16 and you square 3.16, you will not get back an exact 10. Okay, you will get some long chain of values. Okay, so it's always good to use back the values before it rounds off. So BC square equals to 2 square plus 10, so it's 14. Okay, so with that, BC square equals to 14, you take square root on both sides. Same thing, take note, BC equals to plus minus square root of 14. Okay, and of course, after you find the answer, BC will be equals to 3.74 cm. Make sure you have a bracket, reject negative 3.74. Okay, so this is the question 6. Okay, along the way, I did not really pause for anything because if you need to stop to take note of any of the answers, okay, you can always just pause this video. Okay, so next we have in this diagram, okay, they tell that PQ is perpendicular to SQ. This also means that this is a right angle. So over here we do see two right angle triangles, PQR and PQS, okay, where PQR fits within PQS. Okay, they tell that PR is 23, QR is 15, and RS is 17. First, they ask you to find the length of PQ. So like I said, PQ is part of two triangles, it's part of PQR and also PQS. So to use Pythagoras theorem, three sides you need to know at least two sides. Okay, I'm unable to use PQS because I know QS but I don't know PS. Okay, so with that I cannot do that. So I need to make use of instead of PQR. Okay, because I know QR, I know PR. So I know two sides, I can find the third side. Okay, in this case my hypotenuse is 23. Okay, so in this case using Pythagoras theorem, PR square will be equals to PQ square plus QR square. Okay, so same thing, make sure you do right by Pythagoras theorem. Okay, so my PQ square will be equals to PQ square plus 15 square will be equals to 23 square. Okay, then all you need to do, you do some manipulation. PQ square will be equals to 23 square minus 15 square. You can use your calculator. 23 square minus 15 square should give you 304. Same thing, after that all you need to do, take square root on both sides, remember. So PQ equals to plus minus square root of 304. Okay, and then you get 17.4 meters. Reject your negative 17.4. Okay, so yeah, things to take note is units. Like in this case, the question give everything in meters, so the answer will be in meters. In the previous question, everything was in cm, so you just make sure that you give everything in cm. Okay, now that you have found PQ, okay, you can find PS, which is the hypotenuse of PQS. Okay, so now you know PQ, you know QR, yes, you can use it to find PS. Okay, so same thing as the previous question, instead of taking off the rounded off value of 17.4, you should take the square root of 304. Okay, so PQ square plus QS square should give you PS square. Okay, so set this up. So PQ square plus QS square equals to PS square. Actually, I think it's a better practice that every time you write this before you write the substitution. Okay, because if you straight away do a substitution, if you sub wrongly, okay, your whole answer will be wrong. Okay, and this is also clearer, okay, of how you apply the Pythagoras theorem. So now we do our substitution. We know that PQ is square root of 304 instead of 17.4. So we sub in square root of 304 bracket square. QS square is 17 plus 15. So you know this is 17, this is 15. Okay, so yeah, 17 plus 15 bracket square equals to PS square. Okay, so you just need to add this up. So same thing over here. You take the square of the square root, it cancels each other, it's just 304. So 304 plus over here is 32 bracket square. Okay, so you should get PS square is 1328. Over here, they just straight away give you the answer. Okay, but if you key in a calculator, you should get the same thing. Lastly, still the same thing. Take note, PS will be equals to plus minus, okay, square root of 1328. Okay, and you solve it, 3SF 36.4 meters. Okay, reject negative 36.4. Okay, take note, you should not leave your answer just in square root, even though it's so-called the most accurate form. Okay, because this does not mean much to you when it comes to length. Okay, it makes more sense to give it in meters so that you can make sense out of the values. Okay, we have done with question 6 and question 7. Next, we move on to question 10. Okay, question 10. Okay, question 10. Okay, over here, triangle ABC is a right angle triangle. You can see the C is a right angle. Okay, where AC is 5 cm, BC is 12 cm. Okay, tell that D is on AB such that CD is perpendicular to AB. So first they ask you to find the length of AB. You know that triangle ABC is right angle. You know this side, you know this side. You can find the third side. Actually, for some of you might even straight away recognize 5, 12. This is a Pythagorean triplet. Okay, AB will be 13. But of course, even though you know it's a Pythagorean triplet, you still need to show the full working. So you should show, so okay, over here they actually show the preferred working, okay, where actually you first tell me what is the Pythagoras theorem, how does the sides links together. So in this case, AB square, the hypotenuse square, will be equals to AC square plus BC square. Okay, so 5 square plus 12 square. So you write this out first. Remember always to write by Pythagoras theorem. Then you perform a substitution. AC is 5, BC is 12, so 5 square plus 12 square. Okay, so you get AB square should be equals to 169. So after that, you take square root on both sides. Take note, AB is equals to plus minus square root of 169. So the answer should be 13 cm. So AB is 13 cm, bracket reject, negative 13. Okay. So now that we have found AB, they ask you to find the length of CD. Then you're wondering, how do I find the length of CD? Okay, if you look at it from a right angle triangle, it's like I don't know what is AD, I don't know what is DB, I cannot find CD. Okay, so this links back to one of the questions, okay, where we did at the last part of this worksheet, is that we can make use of the concept of the area. Okay, to find the area of a right angle triangle, it's just half times base times height. Okay, so you can take half times base times height, and the key thing is the base times the base and the height. Okay, these two lengths must be perpendicular to each other. They must be at right angle. So in this case, I want to find the area. I can take half times 5 times 12, or I can take half times CD times AB. These two should give me the same value. Okay, so if I know that half times 5 times 12 give me the same as half times AB times CD, and I know what is AB, with that I can find what is CD. So first, okay, I find what is my area. So half times 5 times 12, okay, you get 30 cm square. I know that this area will be equals to half times AB times CD. So AB is this one, CD is this one, okay. So, and I know that AB is 13. Okay, this one you can use the exact because square root of 169 is really 13. Okay, then you substitute in. Okay, you get CD is equals to 60 over 13. Okay, 3SF 4.62 cm. Okay. Okay, I believe in class, instead of doing it into 2 steps, usually I just equate 12 times 5 times half times 5 times 12 equals to half times 13 times CD. Then I just straight away do from there. That is also possible. Okay, you should get the same answer. Okay, otherwise I'll move to exercise 8.2, where we do some questions that is a little more applied. Okay, and the right angle triangles are not as obvious. Okay, you need to find out, you need to come out and with the right angle triangle yourself. Okay, so let's look at this question. We did a very similar question in in our class. Okay, so over here we have A, B, C, D. Okay, cross section of a shed with AB is 2 meters, BC is 2.5, and AD is 1.5. They ask you to find the distance CD. Then we're thinking, I don't see any triangles here. How do I even go about doing it? Okay, over here they also tell that these two are right angles. Okay, so with that, actually that helps a lot in terms of after that how we derive. So like I said, for this kind of questions where the right angle is not present, what you need to do is you come up with your own right angle. You need to observe and come out with it. So in this case, you realize that actually over here, since these two are right angle, I can draw a horizontal line across here and form a right angle triangle here. Okay, so let's take a look how it look like. So it looks something like this. I look at point E, where point E will also be 1.5 meters away from B, just like AD. Okay, so here will also be 1.5. So you know that this 1.5 and this is 2.5. This must be 1. So CE is 1. DE will be equals to AB, which is 2. Okay, because they are all right angles, so ABED is a rectangle. So if this is 2, this is 2, this is 1.5, this is 1.5. Okay, so now you know this is 2, this is 1. Can you find CD? Yes. Okay, so you know two sides. Okay, this is a right angle triangle. You can find the hypotenuse. Okay, so let's look at the solution. Okay, so construct DE perpendicular to BC as shown. So in this triangle, like I said just now, DE will be equals to AB, which is 2 meters. Okay, and then you know that CE will be 2.5, which is BC lah. Okay, minus away 1.5, which is AD, to get this is 1 meters. You know this 2, this is 1. You can apply your Pythagoras theorem. Okay, Okay, so by Pythagoras theorem, so like I said, this is the preferred working. First, write out the relationship before you perform a substitution. So in this case, CD square, the hypotenuse square, will be equals to DE square plus CE square. Okay, so then remember to write Pythagoras theorem. Do your substitution. You know that DE is 2, CE is 1. So CD square should be equals to 5. Okay, so 2 square plus 1 square is 5. Last part, you just need to solve. Take the square root on both sides. Take note, do plus minus. So CD is plus minus square root of 5. Okay, you should get 2.24 meters. Okay, remember bracket reject negative 2.24. Okay, so that's all. Not a very difficult question. Okay, we look at the last question, question 16. Question 16 over here. Okay, so this is a slightly more challenging question. Okay, over here they say that this is an elevator, okay, or also known as the lift, okay, in an apartment block. Okay, it is 1.25 meters long, 1.1 meters wide, and 2.2 meters high. They ask you to find the length of the longest pole, okay, that you can put into the elevator. So the longest pole, meaning what is the longest distance, okay, that I can fit into here. Okay, if I just put between here to here, it's still not the longest because I can actually go from here all the way diagonally to here. Okay, so I think everyone can see that the longest will be from one corner to the diagonal opposite. Okay, so in that case, it will look something like this if you draw it out. Okay, let's call this point A, let's call this point B, let's call this point C. So you'll be at point along AB. Okay, so to find this AB, this is the longest pole that you can put in. How do we find this? Okay, we cannot find it directly. Okay, we need two steps. Okay, because over here, even though, okay, this is a cuboid, so everything is right angle. Even though ACB, over here, this is right angle. But I know that AC is 2.2, but I don't know what is BC, okay, before I can find AB. So in this case, I have an additional step. I need to first find what is BC. Once I know BC, I know AC is 2.2, I can find my AB, okay, using Pythagoras theorem. Okay, so how do you find BC? Okay, over here, this is also a right angle triangle, okay, because like I said, this is a cuboid. So if this is a right angle triangle, 1.1, 1.25, you can find BC to be the hypotenuse. Okay, so let's look through the answers together. AB is the length of the longest pole that can be placed in the elevator. So AC, okay, is 2.2, just now I said that. Okay, so first I need to find what is BC. Okay, so like I say, BC over here, this is a right angle triangle, this is a cuboid. So I know that these two are my shorter length, BC is my hypotenuse. So BC square will be equals to 1.1 square plus 1.25 square. Okay, remember to state that this is because of Pythagoras theorem, that's why you can establish this relationship. Next, you need to solve. Okay, so 1.1 square plus 1.25 square, key into a calculator, it should give you 2.7725. After that, you take your square root on both sides. Take note, BC equals to plus minus square root of 2.7725. Okay, in this case, they did not go and find BC because anyway, we are not finding BC. Okay, and even if we find BC is a round off value later, we will still use back this square before rounding off value. So the perfect value of square root 2.7725. Okay, once I know what is BC and I know that AC is 2.2, I'm ready to find my AB. Okay, so ACB is a right angle triangle. So my AB square will be equals to AC square plus BC square. Okay. So over here, AB square is equals to BC square plus AC square. Do your substitution. BC square is just square of the square root of 2.7725. So when you square a square root, the square root disappears. Basically, BC square is just 2.7725, or actually over here also wrote BC square is 2.7725, okay? And then AC square is just the square of 2.2. You find that AB square is 7.6125. This is an exact value. Okay, then to find AB, same thing, take square root on both sides. So AB is plus minus square root of 7.6125. Okay, after you take square root, remember to reject the negative value. So AB is 2.76 meters, reject negative 2.76. Okay, then write down the statement, okay, to draw the conclusion. The length of the longest pole, okay, that can be transported, okay, will be 2.76 meters. Okay, otherwise that is more or less it for this part, okay, on it for Pythagoras theorem, okay, and some of the application questions. Okay, I think the next portion we'll go through the converse, okay, of Pythagoras theorem. Okay, thank you, bye bye.